In this media example, we're going to create equivalent fractions but with a smaller denominator. So in the last examples, we used a larger denominator. So let's read the directions. Create two fractions equivalent to the given fractions by grouping the total number of pieces into a smaller number of equal pieces. So last time, remember, say we had 1/2, we broke each of the two pieces into more pieces. Here we want a smaller number of pieces. So it's sort of like we're uncutting, okay? And that may not make sense because once you cut something in real life, you can't uncut it. But we want to basically take cuts that are made and regroup into a smaller number of pieces. So now let's look at this first one. Both of these diagrams, the fractions are 8/12, and we're going to make equivalent fractions in the empty diagrams next to them. So here, we can't just break this into any size pieces we want, and here's why. So say I look at this whole, okay, and if I drew lines here, I could break 12 into 4 groups of 3. There's 1, 2, 3, 4 groups of 3 and 12. But notice 8 divided into groups of 3 would be 1 group of 3, 2 groups of 3, and then 2/3 of a group of 3. And we don't want fractions in our fractions, so we're looking to find whole number groupings. And this will require us to use a number that's a factor of both the numerator and denominator. Okay, so 8 has some factors, you might remember. All numbers have themselves and 1 as a factor. 8 is divisible by 2, it's divisible by 4, and itself. 12 is divisible by itself, 2, 3, 4, 6, and 12. Okay, so these are the factors of 8 and the factors of 12, and we need to use common factors. So this idea was common factors or the greatest common factor that we learned in a previous lesson. So I am going to start with 2 because both of them are divisible by 2. So I am going to group 2 little rectangles. Each one represents 1/12. Now I'm going to group 2 12ths together. There's another group of 2 12ths, 2 12ths. And now down here, notice they're not stacked the same way they are here, but 2 of these would be another group, and this is another group. Okay, now let's redraw it over here without all the other lines. And then we had a line here, here, and here. Okay, so this is 1, 2, 3, 4, 5, 6 equal pieces. Okay, and remember, I know these may not look like it, but this piece is the same as these 2 mapped to those 2, so they're the same relative size. Now, which ones were shaded in the diagram? Well, this one, this one, this one, and this one. So 1, 2, 3, and 5 were shaded in the diagram. So we can think of this as 4 out of 6 shaded pieces. So these 4 are shaded, 1, 2, 3, 4, and there are a total of 6 pieces. So 8/12 is equivalent to 4 6. Now let's look at this symbolically. What we did is we took all of the 12 pieces and we grouped them into pieces of size 2. So we could think of that as dividing by 2. And that also divided the 8 pieces into groups of 2. 8 divided by 2 is 4. 12 divided by 2 is 6. Okay. Let's look at the next one. So this is still 8/12, but now we have it in this pizza shape, or circle. I don't think all circles are pizzas, I guess. So now let's look at our common factors from before. So why don't we use 4? So I'm going to group this into 4s, and I'm going to say that every 4 pieces, 1, 2, 3, 4, are now 1 piece. 1, 2, 3, 4. This is our second piece, and this is our third piece. And I know it's a little hard to see, so that's why I'm going to draw this other diagram. Again, pretend they're equal. This was 1 piece, 2 pieces, and 3 equal pieces. Now notice the shaded regions would be 2 of the pieces. So 2 out of 3 are shaded. So 8/12 is also equivalent to the fraction 2/3. Symbolically, we divided the 8 by 4 and the 12 by 4. So we grouped 4 pieces together, making 12 pieces into 3 pieces, 12 divided by 4. And there was 8 shaded pieces. We've divided them into groups of 4, leaving us with 2 shaded pieces.